Hello and welcome to class. Today we are going to be talking about special functions. This is chapter 2, section 5 in the book. And we're going to be talking about three very strange but unique functions that you have probably not seen before. The first one is called piecewise. So a piecewise function is a function using two or more expressions. So it's not just y equals mx plus b. There are two different parts, two or more. Okay, here is what one looks like. So f of x equals, they usually have this big brace there, that's called a brace. And I'm just going to do one with two parts. X squared minus 5 if x is less than or equal to 1. And negative x if x is greater than 1. So that's what these look like. The two parts should be familiar a little bit. Basically, if any of the x's are less than 1, they're going to go in the first equation. And if the y's are greater than 1, they're going to go in the second equation. So let's try it out. Example 1, I'm going to explain it to you. Example 1, we're going to use that function and we're going to evaluate the function above at the given values. So we're going to have part A, B, and C basically. So here's the first one, f of negative 2, f of 1, and f of 4. So we're going to stick each of those numbers into this function and see what we get out. Remember, if the x's are less than or equal to 1, they go in the first one, and if they're greater than 1, they go in the second one. So the first number is negative 2, f of negative 2. Should I pick the first one or the second one? I feel like Dora. Should I go down this path or this path? Since this number is less than 1, we're going to pick the first equation, which is x squared minus 5. So we're just going to stick it in. Negative 2 squared minus 5. Remember to use parentheses. Okay, you guys don't use parentheses and you just say negative 2 squared and you get a negative 4. Negative 2 times negative 2 is not negative 4. It's positive 4, so use your parentheses. And 4 minus 5 is negative 1. Okay, next one, f of 1. Should I put it into the top one or the bottom one? Because this has less than or equal to, we're going to put it in the top one again. X squared minus 5. Whichever one has the equal to is the one that that number goes into. So this would be 1 squared minus 5. 1 squared is 1, and 1 minus 5 is negative 4. Last but not least, we have f of 4. 4 is definitely greater than 1, so it's going to go into the bottom one, negative x. So negative 4 is simply negative 4. Very good, very good. Okay, let's try one more. Same directions, different function. Same directions, different function. This function is going to have three parts. 2 plus x if negative 3 is less than or equal to x is less than 0. 6 if 0 less than or equal to x less than 2. And 1/2 x if 2 less than or equal to x less than or equal to 5. Okay, that's our function, and we have 3 parts again. F of -1, f of 0, oops, and f of 4. So, f of -1, should it go in the top, the middle, or the bottom? -1 is in between. Look where it's in between. It is in between -3 and 0. So it's going to go in the top one. 2 plus x. 2 plus a -1 is 2 minus 1, which is just 1. What about the 0? 0 is in the top and the bottom one, but which one has the equal to? The bottom one. Okay, or not the bottom, technically the middle one. So we're going to use the middle one, and it is simply just 6. Nothing else. It is just plain old 6. And last but not least, f of 4. 4 is in between 2 and 5, so we're going to use that last one, 1/2 x. When we stick 4 in there, 1/2 of 4 is actually 2. So that is how we do that. I'm going to show you how to graph a piecewise function, but honestly, you can do it in your calculator as well, but I'm just going to show you one time anyways. So here's a really easy piecewise. We have x minus 2 if x is less than -1, and x plus 3 if x is greater than or equal to -1. All right. So this is what I would do. I would pick some x's, try to get some y's for the first one, the first equation, and I would do the same for the second equation, some x's and y's for the second equation. The first one is if the x's are less than -1. So I need to have like -1, -2, -3, -4. Right? If they are less than -1. Then the other one says if the x's are greater than -1. So there I need to have -1, 0, 1, 2. So start with the number and then go to the left to the negative or go up to the positive. Well, let's stick those in there and see what we get. So let's start over here. Okay? We're going to stick the x's into the equations one at a time. Remember, we're doing the top equation for the first one. So -1 goes here. -1 minus 2 is -3. Then use -2. -2 minus 2 is -4. Then -3 goes in there. -3 minus 2 is -5. And -4 minus 2 is -6. Now I'm going to use this row and I'm going to stick them in here. Basically, I'm going to add 3 to all of them. So let's do it. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4, and 2 plus 3 is 5. Okay, now let's see if we can go ahead and graph. Looks like our biggest number is going to be -6. So I'm going to go ahead and go to 6 on all my sides. All right, so I'm going to do the left one first, the first top equation. I'm going to have a point at -3, so -1, -3. right here. Then -2, -4, -3, -5, and -4, -6. So something like that. That is the first half. So I'm going to color it in blue. Boop, boop, just like that. The second one I'm going to do in green. So this time I go to -1 and up 2, 0, up 3, 1, up 4, and 2, up 5. So that line looks like that. It looks like we're done. However, I noticed something just now. If I were to draw a line down for the vertical line test, this would not be a function because it crosses the point here and here. So this is what we need to do, okay? You see these two things, less than and greater than or equal to. The bottom one has an equal to -1. So that one should be a closed circle. But remember when we did inequalities, if it does not have an equal to underneath, it has actually an open circle. So inequalities coming back to us here. If it does not have that line underneath, it is an open circle. Now we know what it means if you have an open circle. Now if we draw a vertical line down, it only technically passes a closed circle one time, and that's what we want, because otherwise it is not a function. So that is the piecewise function. We have two more that I'm just going to talk about really quickly. The first one is absolute value. And the second is the greatest integer. Well, I don't want to talk about greatest integer. Let's just talk about absolute value. And I'll talk about quadratics. How about that? Okay, the first one is y equals absolute value of x. And the second one is y equals x squared. So what these look like, I'm going to draw a graph, but it doesn't have to be very precise. Absolute value looks like this. And if you remember, absolute value is the distance a number is from 0. Basically, you make everything positive. So I'll show you very quickly. If we have x and y, if we had -2, -1, 0, 1, 2 for our x's, you make everything positive but keep it the same. 2, 1, 0, 1, and 2. So we have -1, 1, -2, 2, 0, 0, +1, 1, +2, 2. And then for quadratics, if you were to make a graph, let's say -2, -1, 0, 1, 2, we are going to square all of them. So multiply them by 2. -2 squared, well, not multiply them by 2, but multiply them by themselves. -2 times -2 is 4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. So you can see that one kind of looks like absolute value, but it's curved. All right, because let's see, here would be 1, 2 would be up here to 4, and then again 1 and 2 up here to 4. So those are some very important things you'll want to know. You don't have to memorize them, but I just wanted to introduce you. Mainly I want to know that you can plug these numbers into the correct equation, top or bottom. So that's what I want you to know for piecewise. We'll go into these two a lot later on.